Okay, so work problem 8, page 39. Let's have a look at this as an example. So multiply everything in one bracket by everything in the other. So I've got to multiply this by that and this by that, like that. And then I've got to multiply this by that and this by that, and so on for the other one. That times that and that times that. Every term in one by the other. So I always take this one and then multiply it by those two, and then this one, and so on. That's the way I work it, okay? So I'm going to go 3x times 2x is 3 2s are 6, x times x squared. So that's 3x times 2x. Next, 3x times minus 5y. What's that going to give me? Agreed? And so that's that one done. Next, minus 2y times 2x. Sorry, minus 2y squared times 2x is minus 4. Yeah. Minus 2y squared times minus 5y. Minus times a minus gives a plus. 5 2s are 10. Y cubed. Last one. 4xy times 2x. 2 4s are 8. And then 4xy times minus 5y is minus 20xy squared. I'll just pause for a sec while you just check that you see that. Now it's a case of looking at it and collecting like terms. Have I got any more x squareds? No. So it's just 6x squared. Have I got any x squared y? So it's got to be just x squared, Matt. Only x squared. Nothing, not including x squared, but only x squared. Same one, it's got to be exactly xy. Have I got any other terms that is exactly xy? No, so minus 15xy. Xy squared. Yes, I've got that. So minus 4xy squared minus 20xy squared gives me minus 24xy squared. And finally, I've got 10 x squared y next, which is this one. So I've got x squared y and then plus 10y cubed. Okay, exercise 20, question number 6. Let's look at this particular example. From 4x minus 3y plus 2z, subtract this term. What they're saying here is, and this is the key for this, so just focus in. You can always write it down afterwards when I'm going through it, okay? The key here is, when I'm subtracting a term, I'm subtracting the whole term. So in fact, I'm subtracting the x, subtracting the 2y, and subtracting the minus 3z. So we've got a problem where we've got minus a minus. That's the trap in this question, okay, or this sort of problem. So what do? I'm going to subtract like terms, or collect together like terms. Now, I can do it in one go by saying 4x in that term. So the x is in these two terms. So 4x minus x is 3x. Minus 3y minus 2y is minus 5y. And finally, and this is the awkward one, 2z minus 3z is plus. That was what I was going to do next, Tommy. Yeah. Another way to think about it is as follows. I've got, if I look at this again, this part, when I have a number outside a bracket. Let's do a little aside here. 2 times x plus 2y, for example. We know that means I've got to multiply each of the terms inside here by the 2 that's outside. So it's taken as read that if there's nothing outside the bracket, what's there? No, not 0, because 0 times that is 0. So it must be a 1. So we never write it, but there's always a 1 there. So actually, if there's a minus sign there, which there is here, it's actually a minus 1 outside the bracket. And so when you expand out this bracket, as Tommy is saying, you actually end up changing the sign of all the terms inside. Minus 1 times x is minus x. Minus 1 times 2y is minus 2y. So if we apply that to this, I can say this can be rewritten as minus 1 times x is minus x. Minus 1 times 2y is minus 2y. Minus 1 times minus 3z is plus 3z. So I can rewrite this as, 4x minus 3y plus 2z minus x minus 2y plus 3z. And then I can just collect together the x's and the y's and the z. There's two ways of thinking about the same problem. Okay? Alfie? There's another one I wanted to look at. Any questions on that? Exercise 21, question 5. If you can find that. Can you just read it out to me, please, Tom? A squared, b squared. Yeah. We've got to simplify that. Okay. This is an expression. It doesn't equal anything, so it's not an equation. We're going to come to those. It's an expression. This could be a whole series of dimensions in some sort of object, okay? And if you know the laws of algebra, you can actually simplify this expression. That's what this is about. And I want to go about it in two ways, okay? The first way is to think about factorising the top. I cannot cancel anything on the bottom with anything on the top at the moment because I've got an addition at the top. If I have something like this, here's a little aside, 6 plus 4 over 10, we know that answer comes to 1, okay? I can't look at that and say, 2 goes into 6 3 times, 2 goes into 10 5 times. It doesn't work. 3 plus 4 is 7 over 5. I've changed it. It's not the same answer. So if there's some two terms on the top, I can't just cancel one of the terms on the top with one of the terms on the bottom. That's not allowed. Okay? So I can't cancel, and this has been done many times algebraically incorrectly, I cannot cancel that a squared with that a squared for the same reason that I've just explained over there. But somebody, you know, because if you're in the middle of a big algebraic expression, it's all very easy to make a mistake like that. Even if you really know you should, you know, that the rule, you can just slip up. So what you can do though is, if there is one number multiplied by a number on top, 3 times 4 over 6, 4 3 to 12 over 6, the answer is 2. I can now cancel that 3 with that 6 to leave 4 over 2, the answer is still 2. So if there's two numbers multiplied together, I can cancel. So what I do is, I factorise the top. Factorise, if you remember, means take common elements outside the bracket. What's common to both of those terms on the top? Anything else? Right. More than one A? a squared. I can take a squared b outside a bracket. What have I got to times a squared b by to get a squared b? No. What have I got to times a squared b by to get a squared b? 1. What have I got to times a squared b by to get a cubed b? Right, a. Okay. Over a squared b squared. Now I am multiplying this a squared b term, I am multiplying that by the bracket. So I'm in this situation over here, they're multiplied. So now I can cancel. The a squareds go, and that b cancels one of the b's on the bottom, leaving just one b on the bottom. So I'm left with 1 plus a on the top and b underneath. The whole thing cancels down to 1 plus a over b. The other way to think of it, I said there was 2 ways to think of it, so let's look at this one again, and then I'll leave it for you to copy if you want, although the note is on the side. Say again. And this is equally valid. You remember we had, and this is about the fractions, you remember we were talking about last week, v minus u all over t could easily be written as v over t minus u over t when we were, yeah. So we can do that here, look, we can split the fraction and call it a squared b over a squared b squared plus a cubed b over a squared b squared. I can split the fraction like that and put them both over the denominator. Now I can cancel each one. I can cancel a squareds there, and I can cancel that b with one of the b's on the bottom, leaving 1 over b, plus here I can cancel 2 of the a's on the bottom with 2 of the a's on the top, leaving just 1a, and that b cancels one of these, so that leaves a over b. So that leaves me 1 over b plus a over b. But common denominator, so I can combine the common denominator and get 1 plus a all over b, which is exactly the same answer as we had before. Either way would do it. It's just whichever way you see. Okay? And then look at the recording if you get stuck. Okay? One more thing I wanted to point out. Exercise 18, question number 2. Alex, exercise 18, question number 2. Yeah. There's an incorrect solution there. So if you're working through them, the answer should be 16, not whatever it says there. 8, yeah. Exercise 18, question number 2. What? No, you're in chapter 5. Exercise 18, isn't that? Have I got it wrong?
No, it's the first bit on algebra, the first book section.
Have I got the wrong exercise?
We've all got different books.
Right.
Me and Tom had the same problem when you were doing
Yeah.
So
So which exercise do I mean then? Out of the new book?
the first section, 5.1 in algebra.
5.1 basic operations.
Yes, the questions
Yeah, the question.
That exercise that follows that. What's the exercise number?
Exercise 20.
Exercise 20, question number 2.
Is the answer minus 16?
The answer should be 16.
16, not minus. It says minus 16.
No, it's 2. Number 2.
Oh, not 2.
Question number 2.
2 is minus 8.
Yeah, it should be 16. It should be 16.
Oh, okay,
There's an error in the book, yeah.
there's 60, not minus.
16,
Yeah. Okay. We're coming up to the end, but I want to do one more thing. I can see you're itching to go, even though we started late. But that's okay. That's not your fault, is it? No, of course it isn't. It's all my fault, yeah, I realise that. Just 16. Just look back at these aims. We didn't get, I had a feeling we might not get as far as the equation. We'll look at that next time. We've had a look at the function that's used in engineering, and we've looked at some of the rules of algebra. Make time, please, to carry on with those exercises and those questions on the rules of algebra. The next, I think there's a chapter, I made a note of it, if you want to look ahead, chapter page 61, sections 8.1 to 8.5 on equations. That's what we're looking at next time. So if you want to look ahead at that, please do so, okay? And also a reminder again of chapter 10, which is that rearranging formulae chapter. Look at some of those. So it's chapter 8 and chapter 10. You could look ahead at both of those, okay? Right.